CloudGuard AppSec provides a cloud-native WAF with API security, bot prevention, and intrusion prevention. Traditionally, users of WAF solutions had to constantly tune signatures and manage massive amounts of false positives. This led to longer deployment cycles and trading off security by just turning off protection. CloudGuard AppSec is a modern application security solution that offers multi-dimensional security analysis that is fully automated with very minimal policy administration. It uses a two-stage enforcement. In the first stage, it looks at attack indicators like IPs, client-side and user behavior, cookies, and the application session ID. If any of these indicate a suspicious request, it moves on to multiple machine learning engines. It'll correlate the findings of all of these engines to determine whether to allow or prevent the request. CloudGuard AppSec can be deployed as an external reverse proxy or attached to a web server. In this video, we will attach a Linux Nano agent to a pre-existing NGINX web server. We have a customer called Acme Power. They currently have a web application that allows customers to view their power consumption, and it's accessible via the internet. They also have IoT devices that they deployed to each of the customer's premises in the form of a smart meter. This gives them the visibility to the actual power consumption of the customer. They have a web server infrastructure to host the web application for both the power consumption and the API calls. The web servers are running on a Linux platform with NGINX on top. Now, these types of applications are attacked on a day-to-day basis. I have here a SQL engine attack string. Right now, I'm simulating an actual injection attack. When I click on this, what we'll notice is that the graph went down from recording the amount of kilowatts that the customer is using and the amount of money that they're spending on power consumption to 0. What that means is that the attacker themselves are now no longer having to pay for any power. In reality, actual attackers will want to make money off of what they've compromised here. So what we'll do is change the way the numbers are quoted in order to credit the account. Once I start the attack, the power company will owe the attacker money as they credit their account and get free electricity. Now, let's reset the environment and deploy CloudGuard AppSec to prevent this and other attack types. I'll start by navigating to the Infinity portal. I can configure the applications I want to deploy. Click on Add Assets, click on the web application and name it. I chose production for the stage because my environment is live. I'll copy and paste the application URL, which for now is an IP address. I add it and then move on to the next step. I can configure my policy from here because I don't want it to go into the default learning and detection mode. I'm going to go straight into prevent. Now, under normal circumstances, you want to do some learning of the actual application, run it in detection first, and then move into prevention. But because we know that we're being attacked, we put it straight into prevent mode. And you can see here we've got different options to configure. So I'll change my IPS policy to disable just for the sake of showing the flexibility of the configuration. I'll keep the user behavior learning by default, and I'll choose the Linux process. And as you can see from the diagram, this will fit right into the type of topology that we showed earlier. A Nano agent attaches to NGINX as a standard plugin and protects the infrastructure. Now here's my policy. It protects against the OWASP top 10 attacks, botnets, and IPS if we wanted to enable it. I'll move on to protecting the next asset, the API itself. I add a new asset, choose Web API, and call it Acme Web API. It's in production. I copy the URL for the application and paste. I put it into prevent mode right away. And I'll leave web attack mitigation as top level, and this time put IPS into learning mode. I'll leave the user behavior as default. And then I can use my existing profile, which is using the agent. Once I'm done with that, I can go look at the advanced settings before I publish and enforce. Because we're protecting the API, we want to upload the schema. Once that's uploaded, the API protection will include the schema validation as well as machine learning-based analysis of malicious payloads. Now we need to apply the agent to actually do the enforcement. To configure the agent, follow the steps here. You'll run these commands from the Linux server shell, and notice that the token is already copied into the commands. You paste it, and the agent will be deployed. Now I want to check that the status is running by running this last command. We can rerun the attacks now and see how CloudGuard AppSec protects against them. We open up the power consumption web application and let it run as normal. You can see actual values for the kilowatts and corresponding prices. Now when I rerun the same attack as before, CloudGuard AppSec will block it. The meter is still running as it should. So I'll run the second attack. And you can see that the response code is forbidden. So once again, the attack is blocked and nothing has changed from a consumption perspective. Back in the Infinity portal, I'll go into the Monitor tab where these events will be displayed as logs. This dashboard gives you a broad look into relevant security events. You can click on anything displayed here to drill down into it. Important events will have critical and high severity logs. We see that the attack against the web API was blocked through schema validation. If I filter to show logs for the web app asset, we see more types of attacks, like remote code execution and different injection types. On the right side is much more detailed information. You too can protect your web applications against OWASP top 10 attacks, botnets, and other attack vectors with CloudGuard AppSec. For more information, go to checkpoint.com/CloudGuard/AppSec.